Hello, this movie is about very quick and very robust multi-level building uh, point cloud generation. So let's start. So what we will do? We have our data taken from MANDEYE. We launch LiDAR odometry step 1. We process MANDEYE data in folder quick but less accurate and less precise. You will see that it is even not so bad, but very quick. So it is loading data. So we have 9,231 nodes to calculate. The entire LiDAR odometry calculations will take around 16 minutes, so you can just jump with this movie to the 16th minute because we will calculate loop closure. But let's focus now on the LiDAR odometry. So what we can do now, we can just wait and observe, or we can investigate in the middle what is going on in our data set, looking at our preview. So in the folder of our calculations, software is creating a preview subfolder, and it is putting every 100 nodes some sub point cloud. Let's open Cloud Compare and let's load what we have so far, and let's start investigating. It is not so much interesting at this moment because my colleague was standing in one place. We can see his posture here. Yes, he was placing MANDEYE on the ground and start recording. Okay, we have another 400 nodes, or he is starting moving. So we start having structure. What I can tell you that one node is calculated in 50 milliseconds, even less than 50. So at this moment we are calculating already 2 minutes, and we have 2000 nodes of 9000. So let's take a look what we have. Oh, we are starting having nice structure of the surveyed building. Oh, we can see first level. Here we have our final result, so I can show you that we expect something like this. So we have 1, 2, 3, 4, 5 levels and some trees around. Let's back to our calculation. So what we have so far, we have 9,700 from 9,000. So it is around 30, maybe 40%. This is 30, rather 30. We have 3,000. And it looks very promising. Let's calculate maybe the width. So what we have so far, we have, let's say, from this point to this one, we have around 26 meters, and in this direction we have around 30 meters. So you can have impression what we are doing. Let's back to our calculations and let's load almost 4,000 nodes. So we are approaching the middle of the survey. What we have so far, we have very nice first level of the building. It is very promising. I don't see any suspicious mistakes of LiDAR odometry. Okay, so you can see by watching, software calculated for you another 500 nodes, so it is very easy to investigate. In the same time, you can always add more for investigation. Okay, so we have this one. So we have another 400 nodes to investigate. We are calculating already 6 minutes. And we have already almost, more than half of the system. It is calculating even less than 40 milliseconds for one node. So I believe in 5 minutes we can reach final point cloud. This movie is about end-to-end processing of this point cloud of multi-level building due to my colleague's let's say query. He asked me for doing that because I told him that it is almost fully automated and it is very easy and he can do it within 20-25 minutes, and I hope this movie can help more people to reach such a level of processing, because my intention is that this technology is rather easy to use and it's supposed to be self-explainable, but I am reaching still, I am facing still a lot of challenges to deliver you such knowledge, such expertise. I can see that this LiDAR odometry is rather promising and it is great candidate for being a release, so you can enjoy calculations in this release, and I hope you will have similar results from your MANDEYE systems. Yes, it is very, very promising. We have almost finished. I think the calculations can reach only 10 minutes of this 30 by 30 meters. Let's calculate the height. So we have from the bottom to the upper one, let's say this is the, we have around 20 meters height. It's a challenging environment according to my experience, but I can tell that this LiDAR odometry works very sufficient. Even it is turned on in this not accurate mode. What does it mean not accurate? Why it is not accurate? Because the criterion of stop is around 1 or 2 millimeters, so it means that if you are reaching millimeter convergence, so the update is more than 1 millimeter, the criterion of stop is terminating the calculations. So it is not so much tragic in the sense that the precision of the and the accuracy of the LiDAR, LiVox Mid 360, is around 3 centimeters on 20 meters. It means that if your criterion of stop is around millimeters, then it is not so much affecting overall result. Oh, the calculations are done. Now we are saving results to the folder, and it will be possible to perform further calculations in loop closure procedures. So I will launch the second program. Okay, so the preview of the LiDAR odometry is very promising. I think we can tell that the problem that we are facing is it will be very difficult to find, because okay, we have some tilt on the top, you can see here. I will make it closer. So we some rotation. Okay, let's investigate it in another tool. Okay, the LiDAR odometry informed us that data is saved here, and the total length of the calculated trajectory is around 563 meters. Okay, let's check our trajectory, how it looks like. Okay, this is our trajectory. So we can say that we are happy of the trajectory. It looks promising. So the program informed us that data is here. So our session, we will load our session exactly from here. So this is our second step. We load session. So we load session from this location. We wait a moment because the program is loading and downsampling data set. So you can see the trajectory in data set. Let's mark all our points. Let's put some colors, random colors, so it will be much better to see. But this release is much more powerful in the visualization tool because we have something special for you. So let's take a look in new functionality. So first of all, let's show axis, and let's move our entire point cloud in the middle of the origin. So we have to rotate it and translate. For this purpose, unmark simple GUI. Let's go down a little. Unmark manipulate only mark gizmo, and mark gizmo for the first point cloud. And then using gizmo, rotate the point cloud and move it to the center. And then moving down a little. Okay, unmark gizmo, and now we have something like this. So we have our point cloud exactly in the middle of origin, aligned, axis aligned. So we can use our three new functionalities. For example, by marking XZ intersection, you can see XZ intersection. And what we can do in this, we can investigate if we have everything properly aligned. So we can investigate using gizmo. So we can move and we can take a look into the details. So let's change color of the background to see much better view. Okay, to the white one. Okay, and then we can investigate our intersection. So let's move and let's investigate what we see. I can see some problem here. If you believe me or not, we have some misalignment here. Okay, so let's take a look if we have some more problems. So let's fix immediately this problem. Okay, so we have here. So we just entering the mode of the manual pose graph, and then manually let's go to the place that we observed our problem. Okay, so here is our problem. Okay. Okay, this one, I believe. Okay. And then we find another one. Oh, it is this one. Oh, can you see? I found easy the problem. So let's add this edge and then calculate iterative closest point. And then let's set initial poses as an motion model and calculate graph. Oh, now it is better. So let's check if we have another problem. Yes, we have. We have on the bottom. Let's find again next one, next candidate. So we have Or simply we can add manually by reading this 57 and 72. 57 and 72. I will add random colors again. And manually. Okay, give me a second. Oh, this one. Can you see I found the misalignment? So let's add edge. Let's make ICP. And then let's compute pose graphs now. And then back to our intersection. What we have so far? We have another problems here. So let's find another candidates to align. This very nice intersection that we can cope with almost all problems. So let's manual, and then let's find this one. This one. Oh, you can see this intersection tool can help you in locating very quick misalignments. So again, we can check. Oh, it is much better and better. So let's take a look on the top. We have some problems on the top. So we go to the top. The top is around 113 and 141. This is the top. Okay, let's climb more. Sorry. Okay. Okay. Can you see I found some misalignment? So maybe we can make like this. Yeah. We add edge, we make ICP, and then we calculate edge. Okay, let's back to our intersection. I think still we have some misalignment. 1, 2, 3. We have to find these 3 candidates for the misalignment. Okay. Let's find again. So the game is about finding some misalignments. Okay, we found misalignment, so we add edge. And then we compute pose graphs lab. So what we have so far? Oh, we are reaching very, very, very nice, promising moment. So let's find again some misalignment here. It's very, very nice tool, this intersection, you can see. Okay, this one I don't like, this one. So let's find it. Maybe it is this one. I will check again. Not this one. Oh, maybe this one. No. Okay, maybe this one. Maybe this one. Give me a second. Yes, this is okay. We found another one. Oh, I found it. And so let's do some alignment. this one is quite tricky, the tricky one, because it is, we cannot just simply align indoor and outdoor. It's very tricky. So let's try. Let's try to do something. What we can do with that? It's very, very tricky. It's very, very tricky. It's quite challenging. So, because we don't have indoor and outdoor, so maybe we can make something like very, very precise. But give me a second. Okay, so we have something like this. We have something like this. So we will just move it manually down. So we add edge and we use Gizmo and we just move a little down. And then we calculate and everything is much better. Okay, so what we have so far, we have very, very nice. This one misalignment here. So let's find again this one. Oh, after that edge, everything is quite different. So maybe we remove that edge. Maybe we should remove that edge for a moment. So we will just remove edge and we calculate again. So we have this misalignment and we have to live with that. Okay, let's find another intersection XY and let's check if we have everything correct, looking at this intersection point of view. Okay. Looks very promising. Looks very promising. Okay, let's check the last one, the last intersection. Do we have some issues here? I cannot see any issues. Very promising. Obviously, you can spend more time on investigating more issues. You can practice with that. I can see that we have some tilt, but without any other external information, it will be quite difficult to investigate it. I think we can save this result as a very, very nice academic instruction. Oh, maybe I found some nice. Okay, I found one. So let's focus on this last one. So we put Gizmo, we put this one, and then 104. Sorry, not 104. 141. Yes. And then we find Oh, there is a candidate. Give me a second, I will try to find it again. Okay. This is what I was looking for. It is not so evident, but we just add edge and then we make ICP, and you can see that now we can calculate, and it is better and better. So what we have so far, still we have some misalignment here, so let's back to 104. Okay, and 98, I believe. Oh, this one. This one is misaligned, so we add edge and we make ICP, and then we back to compute PostgreSQL. Everything is elevated now, and it is much better and better. I am confused about this one. This one I would like to find. I don't know which one is this one. So let's make the last one. The last one. Let's find the last one. Is it this one? No. It's very difficult to find this. Oh, maybe. No, not this one. This one also no. Maybe. I think so. It's very difficult. You can see that sometimes it is difficult, to justify. Where is it? Ah, so it is in the back. It is exactly in the back. So this one. So let's find. This one is 70. Ah, okay, and this one. Oh, maybe. So the goal is to find the proper edges. Like this one. Let's find the last one. Okay, let's finish this movie around here. Because I am a little late. With this, what I would like to reach. I encourage you to study by your own, but the result is quite promising. Okay, maybe this one. So everything is about looking for proper edge. Okay, that's all for now. I encourage you to study this tool for intersection, that you can use gizmo, you can move, and then you can zoom in, zoom out, and you can investigate your entire system, and maybe you will be very happy of this new functionality. Thank you very much, and I hope you enjoy building such point clouds. See you soon.